energy and work, volume and measurement. Volume is the total space occupied by an object. If the body has a rectangular shape, like say this rectangular block, even if the body has the shape of a cylinder or a sphere, we can find their volume or the total space they occupy by measuring their dimensions. We could find the volume of this block by measuring its length or how long it is. Then we measure its breadth and height. When you multiply that, you will get the volume of this rectangle. Volume is measured in cubic centimeters or as a short form cc. So, how do we find the volume of a body that has an irregular shape? If you cannot dissolve it in water, then you can find the volume by the displacement of water. This method was found by the ancient Greek scientist called Archimedes. Archimedes was given the task to find out if the crown made for the king was made up of pure gold. Wondering how to find this, he went for his bath as was usual in those days at a public bath. When he got into the water, he saw that some water spilled out of the pool. Immediately he realized that this was his solution, and he just ran out, forgetting to wear his clothes, shouting, "Eureka! Eureka!" which means, "I found it." Funny story. Let us try this experiment to understand what Archimedes discovered. We have this beaker of water. Now, a beaker is just simply a jar which has a scale to measure the water in it. We look at the level of water and we write down its volume in cc. Right now, it is 10 cc. Now, we shall add a stone into the water and see what happens. Look, the water level has risen, and that is because the stone is occupying some space. So, the stone is displacing some water according to its own volume. The water level has risen to 30 cc. This means the volume of the stone is 30 minus 10, which was the original level of the water. What do we get? Right, we get 20 cc. So, the volume of the stone is 20 cc. The volume of liquids are generally measured in liters. So, 1 liter is equal to 1000 cubic centimeters. So, volume of liquid is expressed in liters. Let's look at something else about volume. We have these 3 blocks. One is made of wood, one is iron, and the third is copper. All these blocks are of the same size. We can measure them with a scale and they are equal. But if you weigh them, you will find even though they have the same volume, they have different weights. Again, we have a block of cork and iron and lead block and a sponge. We already learned that even though they have the same volume, we know they have different weights. We know that the sponge would be the lightest. If you look at these materials under a microscope, you will find that the molecules of lead are the closest together. The molecules of iron come after that. Then you have cork, and finally the molecules of sponge have the most space between them. What did we understand? Materials whose molecules are closer are denser. So, we are able to understand about the density of the two materials. 1 cc of lead is more dense than 1 cc of cork or sponge. We can also use density to find the difference in two liquids. If we take the same cc of two different liquids and then weigh them, we can find that their weights are different. So, we can take the density of one liquid like water and then use it to compare the densities of other liquid. We have juice in this bottle. Juice is a liquid. Well, liquid exerts pressure on the walls and on the bottom of the vessel. Now, if we make a small hole on the bottom of the bottle, what happens? Suppose you make more holes, one on the top and one in the middle. What do we see? The force with which the water is flowing out from the hole at the top falls the closest. The water flowing out from the bottom hole falls the farthest. This tells us that pressure increases with the depth of the liquid. Our diver can go down only till some level. As he goes deeper, the pressure of water will be too much for him to bear. Divers have to wear special pressurized suits to go really deep. So, the deeper into the liquid, the pressure increases. What did we learn? We learned that liquid exerts pressure. That's a nice ball, right? If I fill it with water and then make some small holes with a needle on all sides of the ball, now if you press the ball, water gushes out and falls nearly at equal distances. This shows that pressure is spread or transmitted equally in all directions. This was the first law proved by a French scientist named Blaise Pascal, and it is known as the Pascal's law. We are going to be learning so much more as we grow up. That's it for now. So, we've learned about how to measure and find the volume of liquid. We learned about pressure in liquids. Oops, you've forgotten your pants like Archimedes. Eureka! And keep learning.